So now we get back into something that can be applied on your dossier to get those higher level complexity points, because we're moving away from creating your own implementation of a list to using libraries that already exist. And the point's been made before, but it's worthy of repeating that to get your 9 to 12 points here in development, your dossier is characterized by the appropriate use of existing tools. So you don't make your own linked list. And it's nice to understand it, and it is part of the curriculum as we've just seen, but in your dossier, for using it, no, you want to use collections that are included in JETS, and the two that are referenced are linked list and array list. These are collections, these are packages that already exist. You can use them, and we'll do that right now. And trace algorithms using implementations of all of them. So, right, tracing. So we'll just construct algorithms using ArrayList and linked list. In terms of tracing them, you've got to be able to trace, and we've done lots of exercises, and hopefully you'll do lots more exercises tracing through to understand what's going on. And before I start in on this with NetBeans, we'll look at this too. The advantages of using library collections is they already exist. So why would you reinvent the wheel? A lot of times the answer to that is because you want to learn how to make a wheel, right? Why do we reinvent anything? Well, you're learning. But for your dossier, you want to use these two. So let's go use them in NetBeans. So a new class in CodeCamp Day 2. We have done this before, but I'm sure this would be a good place to add it as well. And we're not going to do GUI. We're just going to do straightforward. So using linked list and array list. TSVM. So I was thinking about this too, that this needs to be reiterated at some point in all this discussion. What we're doing is working with bunches of stuff. And if we just have an int, whatever is assigned, whatever, fine. If we just have a string, whatever is assigned, whatever, fine. But when we have a bunch of ints or a bunch of strings, we have structures, and those structures can be worked with various ways, and the most obvious structure to work with a group is an array. So let's just go ahead and do that, just to remind ourselves that an int array, single dimension array, we'll call it int array, is going to be made the old-fashioned way, this way. Right? So that is something. Int array is a container. It's something that we can pass to another method. We could go, sort this int array, and somewhere else we would have or this would be void, sorting void, sort this. Sort this would take in an int array I, and it would sort it. Point being that if we have a bunch of ints, we want to be able to work with them together, and we're able to work with them together by making a structure. And that structure is, in this case, an array. But as we know, with arrays, they are limited in that they are not dynamic. So the different kind of, let me do this. So the ones we've seen so far are array, which we just looked at, and list, and list as a QUEUE, stack, and a tree. So those are all structures. They're all things that contain lots of other things. But there are also collections, Java collections, ready-made to work as lists and well, dynamic arrays. And I'll just speak through that usually arrays have the problem that they are static, they can't change in size. 1, 2, 3, 4, 5, 6. That's 6, it's not 7, it's not 5, we can't change it. But with ArrayList, as we're going to see, you can change it. So it's got both the features of an array and the features of a list. So the two of them are, and that's it, you just have to know how to use them. They are, for us, they're there. That's what they are. So we're going to use them. So rather than having an array, we're going to make an array list. So we're going to have a bunch of, we have our pes over here. So let's just use our pes. So we're going to go array list. Actually, linked list is easier. In fact, linked list of type pes list, assign new linked list. Doesn't know what linked list is. And the other thing that's imported is the pes because it's over there in the other package. But we now know what pes is, where to find it, and what linked list is, and where to find it. Or the compiler knows where to find it. So the only question is, really, what can you do with the pre-made linked list? So there are all the different things that we're going to need to know how to use. Add, get, remove. There you can see a whole list of them. And this is for linked list. So most of them work pretty similarly, and we'll try to use one of each group. So we're going to go pes list. Well, we're going to make a pes or two. So we're going to go pes p1 assign new pes, and they take flavor and character, if you remember that. Flavor, fruit, I'm just going to do small words, character, duck. You know what peses are. Look them up if you're not sure. So we're going to add that new pes to the list. So we're going to go pes list, and again, red alert, red alert, red alert. This is something that you can do in your dossier regardless of whether you, like I said at the beginning of the day, have a situation that acts as a queue or have a situation that acts as a stack. If you don't, you can still use the list. So you can still do this, and it takes you closer to those 12 maximum points. So pes list dot, and they're all going to come up. Now I don't see them. Pes, oh, I spelled it incorrectly here. Pes list dot. So there they are. There's all the different stuff that you can do. And we're going to try to keep it to the list that comes from IBCS Jets. So let's for now, let's just add. So we're going to add P1. And then we're going to add another one. Let's do it slightly differently this time. Let's go pes list dot add. And it takes in a pes, right? So we're going to make a new pes. We're going to go new pes. We're going to make it right here. Now that'll work, and that's a fine way to do it. We're taking what we did in 2 lines, we're doing it in 1. We're doing the new pes right here, because that's what add said. Add said we want a new pes. Well, there's a new pes. And we might as well see how this works with remove then, how it's adding them, if it's adding them as a stack or as a queue. So let's just go sout pes list dot, and in terms of what they're getting us to do, like get, let's just, is there just a simple get? Get, no, so we have to get the first or the last. So it's basically forcing us to decide, do we want the first in or the last in. So we'll treat this as a queue, and we'll get what was the first. Well, we're not even sure. I'm assuming that the first is going to be Donald Duck, whatever. So the important thing here, and if you're going to do this, you actually need to understand this now. So I'm going to stop and make sure, Daria, you get this, that this is going to get, can you tell me, what's this going to get? When it gets the first, is it going to get fruit, Donald Duck, or is it going to get a pes?
A pes?
Right. So this is just an object. This is just an address. This is just, it's not going to, we're not going to see anything, right? So we need to go dot what?
Dot.
It's up to you. What do we want to get? We get the character. Okay. Right. So let's see if that's going to get Donald Duck or Minnie Mouse. Gets Donald Duck. So the first was the first that went in, which makes sense actually, but we've proven it. So that's using add, and it's using get first. So let's make this work as a stack. So we want to make it work as a stack. We're not going to get first, we're going to get last. So that means that the last one put on is going to be the first one that we get, or it's going to be the one that we get. So if we run this now, we're going to get Minnie Mouse. And I don't want to make too much of this because, I mean, you know, to get to the point where you can use this, your sophistication program is quite high, but you're quote-unquote just using the stuff that comes up here. If I go pes list dot, you're just using these. I mean, you have to know what you're using and what you want to use. So, like if I wanted to pop one off, does it say pop? It doesn't. So I'm not going to use pop. Yeah, you're moving the first to the last. It's a list, and you're adding to the first to the last, or you're getting from the first. Oh, that's the difference between, right. I will do this. The difference between getting the first and removing the first. So what we did is we got the last. So if we do this again, Daria, what do you think I'm going to see? Because there's get and remove. So if we're doing get once, and then we're doing get again, do you think we're going to get Minnie Mouse Donald Duck, or do you think we're going to get Minnie Mouse Minnie Mouse?
Minnie Mouse?
And it is.
It's last both times.
Right, and it's getting both times. But what if we did this? What if we went remove last?
Minnie Mouse Donald Duck.
Right.
Donald Duck.
Right. And in fact, we'll even make this remove last as well, which means it's going to be empty at this point. But we'll be able to, we'll actually see them both. So we're not just removing them, we're also getting them, but we're getting them and removing them. So when we run it, we're going to see that we do get what we expected. But then if we try to get one more, I don't know if we're going to get an error or what. Let's just see. I think we're going to get an error, which will bring me to the last thing that I want to show you in using linked list, that we don't want that situation where we're going to get an error, right? We want to go if it's not empty. If pes list dot is empty, yeah. So if not is empty, then we're going to do that, right? And we can keep on doing that, which is kind of a silly, but it's an instructive way to do it. So this will run without a problem, because first time it checks to see if this is empty and it's not, so it does this. Second time it's not empty, so it does this. But then the list will be empty. So when it does the third check, if not is empty, well, double negative, it is empty. If I'm saying that correctly, it's not going to get into this because it's not empty. Somehow I feel like I'm saying that incorrectly, but it's not going to get into the final condition because this is going to end up being false. Yeah, double negative there. So that's how you use is empty, to prevent trying to access stuff that's not there. And size is just size. So if we were to print out right now, as list dot size, what are we going to get as our final output? The size is 0 of the list. Up here, what are we going to get? For pes list, right? Pes list dot size. So we're going to see
2 or 4.
2. Yep. So without belaboring this, there are other methods that are listed there, and other methods you're welcome to use if you're using it in your dossier. And again, for the however many time, you can use this definitely in your dossier. So the only thing with linked list is there are a few things that aren't array features. And sometimes it's nice to have array features. So the other collection that you can use is array list. Oh, so it looks like add is an array list thing, is empty is an array list thing, but remove last is not. So it looks like linked list, which makes sense, has these things where you can work with the ends. You can work with the front or the rear, and you can't do that with array list. So let's see what you can do to get them. Array list, we want to dot get, I guess. So it's by index. So, okay, do it, get, and get index 0, and get index 1. And try to get index 1 here, or index 2. We know there is no 2, right? So we're going to try to get index 2, but we'll never get here because, did we remove? All right, well, I'm just going to keep on. This is turning into a little bit convoluted lesson, but it's covering a lot of stuff. So let's trace through this. getting is probably not the same as removing. So we're going to get the character of 0, which is going to be Donald Duck. We're going to get the character Minnie Mouse, second one. But actually, the list is not going to be empty when we get here. And we're trying to get 2. Well, there isn't a 2. There's a 0 and a 1, and there is no 2. And it's not going to be empty, so we are going to get into this. So we are going to get an error when we run this right at the end, and then we'll fix it. Right? Because there is no 2. Rather, what I wanted to do was to empty the array list. So now my question is, can I use some sort of a, well, I can't remove last or remove first. Maybe I can remove an index. So let's just see. And the reason I don't mind me being all over the place here is that this is the way you're going to do it, because you're not going to spend a lot of time probably in class playing around with this, because you can play around with it on your own and understand it by just going dot and seeing what's there. So let's try remove. Yeah, so remove an index. So it's not remove first or remove last, it's just remove. So let's try that. Remove, and we'll remove 0. And then we'll go here. We're not going to get, we're going to remove 1. And, well, we'll try. We'll try to remove 2. We know that there is no 2. But we're never going to get here, because having removed 0, having removed 1, there won't be anything left. And so this will not be true. If not, is empty. Again, figure out the double negative on your own, but we're not going to get it into this. And so we're not going to try to remove 2, and so we're not going to have an error. And when we get the size, at the end, the size will be 0. Okay, this is unexpected. So see if you can, watching the video, get this. What's the problem with this? Remove 0. And the answer is a little bit hard to get here, but let me explain. So we go up here and we remove the 0th. Okay, when we remove the 0th and there are only 2, well, then we're only left with 1, right? So at that point, there's only 1 left, and its named element number is 0. So we would be able to remove the 0 again and get the character, which in that case, second time, is going to end up being Minnie Mouse. And then this is where we would get the error for it's not empty, but trying to remove 2, or in fact we could try to remove 1. But so now the error will slip down to in here, and it's going to say that there's no 2, which there obviously isn't. Oh, right. Okay, double negative, double wrong. What ended up happening was when we removed the 0th, and then there was 1 left when we removed the 0th, which was this, well, then it was empty. It was empty, so we never did get here, and we never did get the last error. So quite a way to end this, but if you follow what I said and follow what's going on with the code, it does make sense. But it just shows you that even though this is straightforward and that you can use the methods as they pop up when you go dot, there's still a lot of stuff to keep in mind and to keep straight. So the end.